All right, welcome to today's lesson on Intro to Circular Functions. This is one of my favourite topics to teach and do, and I've recently learned some new information which actually will help with our understanding of it. So, we're looking at circular functions. This is a picture. You see a picture here of a circle. It has a radius of 1, so the distance from the centre out is 1 unit, whatever that unit is. It could be 1 metre, it could be 1 kilometre, it could be the distance from the Earth to the Sun, which is where this actually came from. You might notice, if you're looking at this, that it sort of resembles the compass face. So you have north, east, south, and west, right? And this is where it starts to make a bit more sense. So the ancients, whoever they were, they sat around and they looked at the sun rising in the east and travelling on this circular path around the earth, because they knew it was a circle back then. And they thought, what can we calculate about this? I know, let's try and calculate how high the sun is in the sky. And what they meant was how far vertically above the ground it was. So they knew that they'd never be able to know the distance to the sun. So they just said, let's call it 1 astronomical unit. The distance from the Earth to the sun is the astronomical unit. We'll just call it one of those, whatever that is. All right? And trigonometry as a whole evolved from that situation, with the ancients sitting around trying to calculate how high the sun was in the sky, because they didn't have much else to do, obviously. All right? So a few things that we use today, and I'll quickly go through those to show you. So first and foremost is that this thing here is called the unit circle, because it has a radius of 1, and that's the only reason it's called the unit circle. All right, so unit circle is that thing there, because a radius of 1 unit, whatever that unit is. All right, now, when we do trigonometry with the unit circle, we don't measure degrees in degrees. We don't, now I said that wrong, we don't measure angles in degrees. All right, we measure in radians. And radians sound interesting, don't they? All right, so first thing is a radian is the 1 radius long. All right, and specifically how long it is 1 radius long on the circumference. All right, so if I took this radius length here and I picked it up and I moved it to be on the circumference, it would be roughly that long there. All right, so stretched across the circumference would be the radius. The gap from this line here to that line there is known as 1 radian. All right, that's a radian. It actually spits out, when you use it in calculations in engineering and things like that, using radians spit out answers that have more meaning than degrees. All right, and degrees are actually used as a bit of an arbitrary judgment because of a few assumptions that people long ago made about the distance around the sun and how long the Earth takes to go and all that sort of thing. It's a good measure, but it's a bit arbitrary. Radians, however, are intrinsically related to the circle because it uses the radius on the circumference, right? So it spits out answers when you use them that are a bit more natural to the circle, okay? Now, people might have noticed that I laid out the radian on the circumference and I went from this point here and I went backwards, not clockwise at all, and that's the measure of the angle. Now you might ask why we do that, and the reason we do that in trigonometry is because of what I said earlier, how this reminds us of a compass. All right, and specifically remember that the ancients were mapping the sun, and the sun always rises in the east and heads to the west. So that's why we measure angles on the unit circle, anti-clockwise. All right? So remember that. We measure angles in degrees. Sorry, we don't measure angles in degrees. We measure in radians and anti-clockwise. All right, that's a really important thing to remember. So first of all, what we're going to try and work on today is converting between degrees and radians, because sometimes questions will be given to you in degrees, sometimes in radians. All right, so to work this out, let's have a look at the circumference of the unit circle. So the circumference of the unit circle is 2 times pi times the radius. And that's quite nice because we already know that the radius is 1. So the circumference of the unit circle is 2 pi. All right, so that means that if I use the radius, there should be 2 pi of them around the circle. All right, so roughly speaking, pi is 3.14, which means there's about 6.28 radians in a circle. All right, now roughly speaking, because that's a rounded off. Okay, what we'll try and do is always refer to angles using a combination of pi so that it's exact. All right. So then that tells us that the full circumference is 2 pi. So the distance from here counterclockwise all the way around there on the circumference and back to the start is 2 pi. All right. So there are 2 pi radians in a circle. All right. So now we know that there are 2 pi in one circle. Oh, that's a terrible way of writing circle, isn't it? We already remember that there's also 360 degrees in one circle. So that leads us to the assumption that 2 pi is the same as 360. All right? So that means that half a circle, half of 2 pi is pi, half of 360 is 180. All right, so pi radians is the same as 180 degrees. All right, so that then leads us to a little ratio that we can use to convert from radians to degrees and vice versa. So the ratio we can use is just pi over 180, or its reciprocal, sorry. All right, and the one we use depends on what we want the answer to become, or what we're trying to convert into. All right, so to do a few examples, let's try and convert 30 degrees into radians. All right, so I'm going to start with degrees. So I'm going to have 30 degrees multiplied by something, and I want the answer to be radians. And I haven't mentioned it before, but the symbol we use for radians is a C. And it's often left off, but if you see it in place of where the degree sign should be, you know that it's talking about radians. All right, so now here's where we get to choose this either pi over 180 or 180 over pi. So looking at this label here, that's degrees. Now, labels can cancel out just like fractions could. So this label of degrees is on the top. I need it to cancel out, and the only label left to be radians, which means that the label in this ratio needs to be degrees on the bottom. So there's 180 on the bottom and radians on the top. Okay, so I can see here that that label is going to cancel with that label. I'm going to have 30 times pi over 180 equals something or other, and the only label left is radians. All right, so let's just start cancelling out as much as we can. The zeros can go. 3 over 18, that leaves pi on top and 6 on the bottom. All right, now pi is an irrational number. So when we're converting into radians, we often don't simplify into a decimal. We are happy to leave it as pi on 6. Okay, and that becomes really helpful a lot later on. Or actually not a lot later on, just around the corner. Okay, so this is the angle. We go, it's pi on 6 radians. So pi on 6 radians. The C stands for radians. All right, so let's have another look at a different one. What about if we were to convert pi on 4 radians into degrees? All right, so I'm converting an angle in radians to degrees. So pi on 4 multiplied by something, and the answer has to be degrees. So again, I need the answer to be, the label in the answer to be degrees. Therefore, the radian label has to cancel out, which means it needs to be on the bottom. So the ratio I'm looking for is 180 over pi. You can see here that that radian label will cancel, leaving me with just the degree label. All right, so I've got a pi on top, a pi on bottom. So the pi's are gone. 180 divided by 4 is going to give me 45 degrees. All right, so you notice that when I convert back to degrees, I've got a nice number that I'm used to dealing with. The irrational pi has gone, all right, which is what we know from degrees. We're not used to having irrational numbers like pi when we talk about degrees. We're used to having whole numbers or decimals, which is what spits out this end, okay? So in general, and here's a good thing to remember for the future, if the angle has a pi in it, then you're most likely looking at radians, all right? If the angle doesn't have a pi in it, you're most likely looking at degrees, okay? That's only most likely. You need to very carefully read the question because they might give you a hint or tell you directly in there. And you also need to look for the symbols if they've been used. A lot of the time though, when we do trigonometry in methods, we will list angles like pi on 6, and they won't have the C symbol after them. They'll just be, this is equal to the angle. And we assume, because the pi is in there, that it's being measured in radians. All right? So, on your Casio, at the bottom of your screen, you now know what that, the word deg, rad, or grad does. Okay, so deg is degrees, rad is radians, and grad we haven't touched upon. So if we're doing trigonometry and you see an angle with a pi in it, you'll need to make sure it's in radians. If you're doing trigonometry and you see an angle with this sign in it, you'll need to make sure it's in degrees. All right, there is a way to convert directly from degrees to radians on your calculator, but arguably it's just as long as typing in an entry line like this and having it do it for you. All right, so to recap, this lesson, short and sweet, we have the unit circle, which is a circle with a radius of 1. We don't measure angles in degrees in these unit circles, we measure them in radians. Radians have the symbol of a C, and a radian is one radius laid onto the circumference of the circle. We know that there are 2 pi radians in a full circle, which leads us to the ratio of pi over 180 or 180 over pi, and we use these to convert from radians into degrees. Your calculator can do it too, and the deg, rad, grad is that conversion or spits answers out in the given format.